Hey everyone, today we are going to go over the quiz on vectors. Component form is by far probably the most important thing, so make sure you know how to put something in component form, whatever that means. From a picture, from points, from a story problem, anything. So component form is the big deal. So that's mostly what we're going to go over today. If we have a head and a tail, remember it is head minus tail. And component form must have these kind of brackets. Put the x's with the x's, so we have -3 minus 4, and the y's with y's, so 1 minus 8. Order obviously matters because we're subtracting. Component form is -7, -7 in this case. This is the symbol for magnitude with the absolute value bars. It's also the symbol for absolute value when we get to complex numbers. Same thing. Distance, hypotenuse, Pythagorean theorem. So that's what we're looking for. So we're going to use the components, of course. So we have the square root of a squared plus b squared. If you're going to bother putting the negative in with the number, any number, then you need to put parentheses around that, especially if you're going to use the calculator. It makes way more sense to just go ahead and square the numbers without worrying about the negatives. And so when you simplify this, this, of course, is 7 radical 2, because it's a 45, 45, 90, because the sides match. Then, of course, the graph. The tail is at 4, 8, which this graph is, I'm going to approximate just because I can't really see it too good. And then the head, which is the arrow, is at -3, 1. And so the direction in which it points matters, and make sure that is correct. When you have equal vectors, their components need to be exactly the same. Not part of the components, not sort of, right? They need to match. Same signs, same x and y values. So these do not match. So the vectors are not equal because the component form, if I can spell, the component forms are not the same. So again, component form is really a big deal. I don't know if I've said that enough, but I'm going to keep saying it. Now, for number 3, we're going to add these up. They are already in their component form, so we add the x to the x. So 2 plus -5, and actually the b, add the b to the b, so 5 plus -3. So the answer is, of course, -3, 2. When you go to graph this, since we're adding, it doesn't really matter which one you graph first. I'm going to graph S first. And of course, you start from 0, 0. So the component says we're going to go right 2 and up 5. So this is vector S, labeled it. We graph tip to tail, so vector T is negative, so that's going to be left 5 and down 3. And then so there's vector T. And then your resultant goes right here. So the green one is the resultant. That's this one, the short little one here. And so that is, of course, vector S plus vector T. Now for this one, the directions are a little bit better. This, as you can see, gives you the order. I know that one just said add the two. It didn't really say what order. This one, of course, you can see it definitely says V minus W. So we're going to do it in that order. -1 minus 3. And for the b value, 7 minus -5. So the new symbolic method that numbers -4, 12. Now, to do it graphically, of course, we graph. The order matters on this, so we have to graph v first. So v is -1, 7. Just pretty tight to that axis. Then when you subtract, we're subtracting vector W. So that's going to be changing the signs on vector W. Oops, I'm talking and writing. So it's going to be the opposite of this, so -3, +5. So we're going to count left 3 and up 5 from here. That is vector, opposite of vector W, and now your resultant, I'm going to do that in green again, is out here. So it's very, very tight, maybe even a little bit too hard to see, but if your graph doesn't show up so well, like if your grid, you can't really see it, no worries, just do the best that you can with what you have. I know sometimes the copies don't look so good. And that doesn't look so good either, so that's what you get. Now, when you multiply by a scalar, of course, that's distributive property. So 3 times vector u is negative 6, 9. And again, all of this is in component form. And when you graph this thing, you have to graph it tip to tail. So we're going to go left 2, up 3. Then we do it again, left 2, up 3. And we do it one more time. It takes you right to the corner. This is vector u, this is vector u, and that is vector u. Computing magnitude and direction. Of course, again, you need component form. That's weird. So we have 2 different starting points. Number 6, we don't have component form. So what is your plan to get this? Are you going to find the coordinates of the head and then find the coordinates of the tail and subtract? Are you just going to count the squares? It's up to you how you want to do this. If you count the squares, you go A first. So it goes 1, 2, 3, 4. So it goes to the right 4. And then obviously this goes down 6. So that's the component form. Or you could actually find the coordinates. The head is at 5, negative 3. And the tail is at 1, 3. And then you can subtract those. Again, it would be head minus tail. But now that you have the component form, we can find the magnitude. That's the symbol for magnitude, absolute value. It's the square root of 4 squared plus 6 squared. And that is, of course, 52. And 52 breaks down into 4 times 13, so 2 radical 13. Then the angle for the theta would be the inverse tangent equals b over a, negative 6 over 4. So this gives you right around negative 56. I'm not trying to write down the whole decimals, but that's the approximation. We want to make sure that this ends up in the 4th quadrant, because if you move your axes over, this guy's in the 4th quadrant. You can have negative 56.690. Or if you want to add 360, it doesn't say what the answer should be, 303.690 degrees. So either one is going to be okay, because it's in the 4th quadrant, so that is the correct value. Now for this one, we have component form. So the magnitude, I'm just going to call it vector v again for lack of a name, 3 squared and 5 squared. And so this is, of course, the square root of 34, and that does not simplify. For your angle, we do inverse tangent, b over a. Now, negative 3, 5 is in the 2nd quadrant. So make sure that your answer is in the 2nd quadrant. You are going to have to adjust this, and you're going to have to add 180 to your answer. We get 120.964 degrees. To resolve something into its components, you do magnitude times cosine of the number. So 10 times cosine of the angle, rather, the direction. And then you do magnitude times sine of the direction. This is a unit circle value. It's over here. It's 30 degrees away from 180. So we know that the cosine is negative radical 3 over 2. And we know that the sine is negative 1/2. So no decimals here because of the fact that it's on the unit circle. So we get negative 5 radical 3 and then negative 5 for the b value. Argument, absolute value, and all operations with complex numbers. You can definitely expect to see this. So for the argument, this is the angle. So we're doing inverse tangent of b over a. In this case, b is the negative 3, a is the 4, right? Because this is a plus bi. So we don't want the I. Do not put I in with tangent. It's right around negative 36 point something, which you can call it that, or you can add the 360, and we get that the theta is 323.1 degrees, or you can leave this as negative 36.1 degrees. Completely up to you. Because this is in the 4th quadrant. So we're good with either angle measure. Absolute value is magnitude. So this is square root of, or 4 squared plus 3 squared. 16 plus 9 is the square root of 25, so this is 5. Then we graph it. You're going to start at 0, 0. So the real goes left and right, so our real is a positive 4. Imaginaries are up and down. The imaginary is negative 3. And so there is your number. You will have your calculator for this. Of course, all radicals are going to not be able to be done on the calculator, but the rest of this should be. When dealing with imaginary or complex numbers, you should use parentheses. The calculator just likes it a little better, although I don't know why you would use the calculator on this problem. We have negative 3 plus 2i minus 4 minus I. Combining the real numbers, you get negative 7. Combining the imaginaries, plus I. For this one, again, you should use parentheses, especially if you're going to use the calculator. This is distributive property. I would use the calculator on this one just because it's a little bit harder. So we get negative 14 plus 5i. And especially on division, use the calculator, and you're going to have to use parentheses. 3 plus 2i, unless you have the fraction key, and you don't need the parentheses then. No fraction key, use the parentheses. So here we get negative 10 plus 11i over 13. Yes, that will be a quiz. These on the last page are also going to be on the quiz, because these are the good ones. So we have people on spring break seeing a shark in the ocean, but safely on the beach, so they're not going to get hurt. That's nice. Shark travels 80 degrees north of east for 12 kilometers, and then he turns and travels 20 degrees south of east for 8 kilometers. How far is the shark from the people? To the nearest kilometer. So to the nearest kilometer. So we're going to have to pay attention to that. So we've got what? First quadrant, it seems like, because they seem like positive numbers, and first quadrant angle. So 80 degrees north of east. So this way. And this is the 80-degree angle here. And the distance is 12. Then, of course, we redraw. And now we're going to go south. So 20 degrees south of east. So now we're going to look like this, and this is going to be negative 20, and that's for 8 kilometers. And then, of course, the question says, how far is it from the people? We'll just assume the people were right here at the origin. So this is going to be resolving this into component form. We just did this. We had a unit circle value, so we didn't have any decimals. So we have 12 cosine of 80 and 12 sine of 80. And to that, we are adding 8 cosine of negative 20 and 8 sine of negative 20. I like to add these up and down. We just want decimals. So nearest, we'll go 3 decimal places, 9.601. And of course the B value is 9.081. Distance is magnitude, so now we'll use the magnitude with these numbers. And again, this is going to be straight up calculator just because of all the decimals. So we have 9.601 squared, 9.081 squared. Throw that underneath the radical sign. And remember, we are going to the nearest kilometer. So it's like 13.215, something near there. So this is 13 kilometers. Now, to the nearest degree, and in what direction? Well, I don't know if you can tell by my little red directional guy. He looks like this. If I blow him up a little bit, that's that. So this is west, this is east, this is north, and this is south. So it looks like it has to go south of west. But we don't know how many degrees. To the nearest degree. So again, whole number. So we're looking at inverse tangent of b over a. This is where you get b over a from. So 9.081 over 9.601. Throw that in the calculator, it's like 43.406. which we're going to call 43 degrees because we're going to go to the nearest degree. Last one. Just to make this easier, on the quiz, I labeled these better after realizing this was pretty difficult to sort of identify what was happening. So sorry, label them yourself. I'm just going to call them A, B, and C just because, you know, I don't really have better names than that. So A is at 1, 2. B is at 3, 4. And C is at 2, 5. Now when you label a triangle, the lowercase goes across from the capital. This will help us kind of identify what's happening. Now, I like to count the squares. Wait, why do I feel like that's not right? I guess maybe it is. So I don't mind counting the squares to get my component form. So I know that sounds maybe weird. So the component form for A, it looks like you went down 1, left 1. So this is going to be -1, or right 1, sorry. As long as you're consistent, it doesn't matter, but you got to do them all the same. So I'm going to go up and down first, and then I'm going to go left or right second. Vector B. Why am I so confused? Sorry. Vector B looks like its components are -3, -1. And vector C looks like its components are this guy, -2, 2. -2, -2. So what we're going to do from this is we don't really care about the components. What we want is the length of each side. And so this is magnitude. So we have the square root of 1 plus 1. So this is the square root of 2. This one is the square root of 9 plus 1. So this is the square root of 10. And this, of course, is the square root of 2 squared and 2 squared, so 4 plus 4. So we're dealing with the square root of 8. Now, I know the square root of 8 simplifies, but I'm not going to simplify it. So now we have to find the smallest angle first, because if you don't, it could possibly throw off the whole problem. And I don't know if it does on this problem, but you don't know either. So there, we're going to go small. And then after you find the smallest, it doesn't matter which one you find. So the smallest one is opposite the smallest side. So this is the smallest side, which I've called A. So I have to find angle A first. So if I start with side A, radical 2 squared, then it does it, the other two don't matter. Square root of 8 squared, square root of 10 squared minus 2 times square root of 8, square root of 10. But what matters is I'm ending with the sine, or sorry, cosine of A. I'm going to simplify this a little bit because this is so easy. This is 8, this is 10, so this is 18, and this is -2 square root of 80, which I don't really care to actually know what that is. I'm going to put it in the calculator anyway. I'm just trying to make it less to enter into the calculator. So we're going to do 2 minus 18 divided by -2 radical 80, then second cosine, second answer. If you do it right, we'll get that angle A is 26.565 degrees. So now we're going to switch to the law of sines. So I'm going to start with that one. The sine of that angle, which is 26.565, over the side across from it. Now we know the side across from it is radical 2. Now it doesn't matter. Doesn't matter. I'm going to go with I don't know, square root of 8. How about that? I don't know, I'm just picking one. Over the sine of this, of course, would be angle C. Put this in the calculator. You go in this diagonal first, divide by the square root of 2, second, sine this time, second, answer. And I've labeled these weird from what I have written down, so I'm believing that angle C is like 44.9998. So I'm going to call that 45 degrees. Or you can just call it, 44.999 if you want. And then we have angle B to find. So angle B, we're going to subtract from 180, and this would be 108.435. So that, of course, is the largest angle because it's across from the longest side. You will get the law of cosines as a formula. It will be right on the test. Yeah, you will. And then I guess you'll get the law of sines too, because you need that too. So we'll put all that on there. But no other formulas, no component form formulas, no magnitude, no direction, none of that other stuff. So make sure you know those.